Uh, Students, so we will see the punching press where we use the flywheel in the punching press machine. The function of the flywheel in an engine is to reduce the fluctuation of the speed. See, when the ram is going to do some work on the material or work material, okay, there the energy will suddenly reduce. So because of that, the speed will also get reduced in the flywheel. So to avoid these fluctuations, what happens? This flywheel is used to reduce the fluctuation of the speed when the load on the crankshaft is constant and the input torque varies during the cycle. Okay. Here the flywheel is used to perform the same function when the torque is a constant and the load varies during the cycle. So when the load on the crankshaft is a constant and the input torque varies, also we can use this flywheel. Similarly, when the torque is a constant and the load varies during the cycle, there also we may use this flywheel. So such an application is found in punching press or in a riveting machine. So this is the schematic representation of a flywheel where this R denotes the radius of the flywheel, and the theta 1, theta 2 are the initial and final positions when you measure certain speed, omega angular speed. And this is a tool and the job. The tool has to enter or it has to be do some measuring operation on the job. Okay, what happens when you give the load, there happens the fluctuation of energy, and because of that fluctuation of speed happens. So to avoid the fluctuation, we are going for this particular flywheel. So the flywheel, what it stores, it compensates the fluctuations and it provides a uniform motion. So that is what here, assuming the uniform velocity of the tool, this angular displacement by 2 pi radian, that is for 360-degree revolution, is considered as a T by 2s, or we can say T by 4r. So this is the problem in the punching press where it is frequently asked. When we will look at the question first. A punching press is driven by a constant torque electric motor. The press is provided with a flywheel that rotates at maximum speed of 225 rpm. The radius of gyration of the flywheel is 0.5 meter. The press punches 720 holes per hour. Each punching operation takes 2 seconds and requires 15 kilonewton meters of energy. Find the power of the motor and the minimum mass of the flywheel if the speed of the same is not to fall below 200 rpm. So this is what the question they have given. A punching press, it is driven by a constant torque electric motor. The flywheel is provided with the press is provided with a flywheel which rotates at the maximum speed of 225 rpm, that is N max. Radius of gyration K, that is equal to 0.45 meter, and the hole punched, there is a number of holes punched is 720 holes per hour, and the energy it requires is 15 kilonewton meter, and the time taken for each punch is 2 seconds. And if the flywheel drops its speed to 200 rpm, we have to find out the power of the motor and the minimum mass of the flywheel. Okay. We will solve this problem in the next session.